Using an uninterruptible power supply, or UPS, as an emergency power unit specifically for charging batteries presents several potential drawbacks. Firstly, reliability is a concern. UPS units are primarily designed to offer temporary power during brief outages. Their reliability for continuous operation over extended periods, as needed during an emergency, may be questionable. The internal batteries within UPS units degrade over time, impacting their runtime capacity and overall reliability. Secondly, capacity is an issue. Most UPS devices have limited battery capacity. This can make it difficult to provide sufficient power to charge multiple batteries simultaneously. Thirdly, fire and safety hazards must be considered. UPS devices aren't engineered for continuous operation, especially when dealing with high loads. Overloading the system or using it for prolonged periods can lead to overheating, posing a fire hazard, and potentially damaging the device. UPS units often use lead-acid batteries, which can release toxic gases if they are damaged or mishandled. Fourthly, adherence to National Electrical Code, or NEC, is crucial. UPS units must be under ITIS laboratories, or all listed and comply with NEC codes when used in permanent installations. Using these devices in non-approved ways might violate safety regulations and could void warranties. Other considerations include noise. While UPS units are generally quieter than generators, they still produce audible noise when running. There is the cost to think about. High-capacity UPS models can be expensive. Finally, UPS units are not as efficient as generators when converting fuel into power. In conclusion, using a UPS as an emergency power unit to charge batteries might seem like a convenient option. However, it is not generally recommended. This is due to the potential problems with reliability, capacity, fire and safety hazards, and possible NEC code violations. Opting for a generator or a purpose-built emergency power solution that meets safety standards and offers reliable power is the better choice. To expand on the potential fire and safety hazard, consider these points. The continuous cycling of the UPS charging circuit when used for prolonged battery charging could stress the internal components beyond their design lifespan. This can cause premature failure and increase the risk of overheating. Lead-acid batteries, commonly found in UPS systems, contain corrosive electrolyte. If the battery casing is damaged or cracked, this electrolyte can leak, causing damage to surrounding equipment and posing a chemical burn hazard. When charging lead-acid batteries, hydrogen gas can be released. In poorly ventilated areas, this gas can accumulate and create an explosion hazard if ignited by a spark or flame. The heat generated by the UPS during continuous operation can also accelerate the degradation of nearby flammable materials, increasing the risk of fire. Furthermore, the internal wiring and connections in the UPS may not be rated for the continuous high current demands of charging multiple batteries. This can lead to overheating of the wiring, insulation breakdown, and potential electrical shorts. From an NEC code perspective, improper use of a UPS can lead to several violations. For example, NEC Article 400.8 prohibits the use of flexible cords and cables for permanent wiring, which may occur if a UPS is used to power essential circuits for an extended period. Additionally, NEC Article 110.3b requires that all equipment be used in accordance with its listing and labeling. Using a UPS for purposes outside of its intended design violates this requirement and could void its UL listing. Also, NEC Article 700 addresses emergency systems. To comply with NEC, emergency power systems must be designed and installed to provide reliable power during outages. Using a UPS as a substitute for a properly designed emergency system might not meet these requirements and could result in code violations. Furthermore, NEC Article 701 covers legally required standby systems. These systems provide power to loads such as heating, ventilation, and air conditioning systems in commercial buildings. Using a UPS in place of a legally required standby system could violate these requirements if it doesn't meet the NEC standards for capacity, reliability, and runtime. Another point is that NEC Article 702 addresses optional standby systems, which provide power to non-essential loads during outages. While using a UPS for optional standby power might seem acceptable, it must still comply with NEC requirements for wiring methods, overcurrent protection, and grounding. Failure to meet these requirements could result in code violations. There are additional things to consider. The long-term cost of operating a UPS as a battery charger may be higher than using a dedicated battery charger. UPS units are not designed for continuous charging and discharging cycles, which can reduce their lifespan and require more frequent battery replacements. The charging efficiency of a UPS may also be lower than that of a dedicated battery charger, resulting in higher energy consumption and increased electricity bills. Using a UPS as a battery charger can also limit its availability for its intended purpose. If the UPS is constantly being used to charge batteries, it may not be available to provide backup power during an actual power outage. This could leave critical equipment unprotected and vulnerable to data loss or damage. A further point is that UPS units typically have a limited number of output receptacles, which may not be sufficient for charging multiple batteries simultaneously. This can require the use of power strips or extension cords, which can overload the UPS and create a safety hazard. In addition, the cooling fans at a UPS can be noisy and disruptive, especially in quiet environments. Continuous operation of the UPS as a battery charger can exacerbate this noise problem and create an uncomfortable work environment. Another factor to consider is that UPS units are designed to provide a stable and clean power supply to sensitive electronic equipment. Using a UPS to charge batteries can introduce electrical noise and voltage fluctuations into the power supply, which can damage sensitive equipment. Also, UPS units typically have a limited warranty, which may be voided if the unit is used for purposes outside of its intended design. This can leave the user with no recourse if the UPS fails prematurely due to overuse as a battery charger. It is important to note that using a UPS as a battery charger can also create a false sense of security. Users may assume that the UPS will provide reliable backup power during an outage, but the unit may be overloaded or have a depleted battery due to continuous charging. This can lead to unexpected power failures and potential damage to equipment. Moreover, UPS units are not designed to be used in harsh environments, such as those with high humidity, dust, or extreme temperatures. Using a UPS as a battery charger in these conditions can shorten its lifespan and increase the risk of failure. And UPS units typically have a limited surge protection capability, which may not be sufficient to protect equipment from power surges caused by lightning or other electrical disturbances. Using a UPS as a battery charger can also reduce its ability to provide surge protection to connected equipment. Lastly, UPS units are not designed to be easily serviced or repaired. Replacing a failed battery or other component can be difficult and may require specialized tools and expertise. Using a UPS as a battery charger can increase the likelihood of component failure and require more frequent servicing. Considering all of these factors, using a UPS as an emergency power unit to charge batteries may not be the best solution. It is important to carefully weigh the potential risks and benefits before making a decision.